Melody, what diagonal did you draw in?
KT.
And what is that? Is that a plane? Is that an angle? What is that?
The diagonal.
Uh-huh. What geometric shape is that?
Segment.
Segment. Okay, so so segment KT, that diagonal KT, when drawn in, I do agree that it divides this kite into two congruent triangles. But Allie, Malone, how do I know those two triangles are congruent? By side, side, side. Both those triangles share segment KT, so segment KT is congruent to itself by the reflexive property. And so I know that triangle KIT is congruent to triangle KET. And then by side, side, side. Awesome. Pretty easy. Now, it says draw the other diagonal and explain how you know the diagonals are perpendicular. So it wants us to, I'm going to go ahead and erase this because it gets in the way. So it wants us to draw in this diagonal, and obviously these two diagonals are going to intersect. And when two segments intersect, they're always going to intersect at exactly one point. Let's just call that point D. So everyone's on the same page. So we've drawn in our second diagonal. We know that they're going to intersect, obviously. We just called that point of intersection point D. Now, what they want you to do is prove, convince yourself, and convince me, that these two segments are perpendicular. If you're having difficulty with this, try to work backwards. Our end goal is to prove that two segments are perpendicular. If two segments are perpendicular, then what kind of angles are being formed? Right angles. I mean, that's the only way we have proven if two lines or segments are perpendicular, is if they intersect forming right angles. So we need to somehow prove that this is a right angle. Well, the only way that we've experienced, the only experience we've ever had with that, of showing that an angle is a right angle, and not knowing, excuse me, and not knowing that the segments were perpendicular, is showing that its measure is 90 degrees. There's no other way of doing it. Because we don't know if those segments are perpendicular. So our only hope by showing that, or to show that this is a right angle, is to prove that the measure of that angle is 90 degrees. Does everyone agree? Is that okay? So how do I show that the measure of that angle is 90 degrees? Right now, the only thing I know about that measurement, the measurement of this angle, is that this measurement is going to be congruent to this measurement. I'm sorry. Ooh, just a minute. The measurement of this angle is going to be equal to the measurement of this angle. What else do I know about the measurement of that angle? So, Cheyenne? When we add the measures of these two angles, it's going to be 180 degrees. When we take the sum of these two as well, because those are a what? Linear. They're a linear pair. So right now, I know that I need to show that this is, the measure of this angle is 90 degrees. Well, the only thing I know about the measurements is that, that these two add up to be 180 degrees. Well, if this one was 90 degrees, and this one was 90 degrees, then they would sum up to be 180 degrees, right? So if two angles have the same measure, then they are what? They're congruent. So can we prove that these two angles are congruent? So if we can prove that these two angles are congruent, then we're going to say, well, if they're the same size, same shape, then they need to have the same measurements. They're supplementary, so the only way that they can be congruent and supplementary is if they're both right angles, they're both 90 degrees. So how can we prove that these two angles are congruent? Remember, if you prove triangles are congruent by using three facts, like we use side, 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 well, once we do that, what else do we know? Once we prove that the triangles are the exact same size, same shape, what else do we know?
All of their parts are congruent.
all the other parts that we didn't originally know about are congruent. So can we apply that theorem, CP/CTC, can we apply that to these two triangles? Okay? So this top triangle and this bottom triangle, we proved that they were congruent by side, side, side. Well, if that's the case, then I know that that angle and that angle are congruent, because they're corresponding parts. I know that this whole angle is congruent to that whole angle, because those are also corresponding parts. And then I also know that this angle is congruent to that angle. Some of you on tests and quizzes wrote definition of congruent triangles. I'm okay with that. I mean, if you have two congruent triangles, then that means all parts are congruent. Or I'm sorry, all the corresponding parts are congruent. So, if we can somehow prove that this triangle, so now I'm talking about triangle KID, is congruent to triangle KED, if I can prove that those two triangles are the same size, same shape, then I know, let's go ahead and erase this because we don't know that yet, then I can say, well, this angle here is corresponding to this angle. So if I know the triangles are congruent, then I know that these two parts must also be congruent. And then that would lead us to proving that the segments are perpendicular. So if you get stuck like that, try to work backwards and say, okay, if that's my end goal, how in the world am I going to get there? So let's go ahead and do that right now. So in red ink, in green ink is what we did for part A, and red ink is what we're going to do for part B. So I drew in my diagonal. I just chose point D as where they intersect. I know that segment KI is congruent to segment KE. How do I know that? If this was a proof, what would be my reason? Given, right? So this is given to me. I also know that angle DKE is congruent to angle DKI. What's my reasoning on that? CP/CTC. Okay, I proved that these triangles were congruent. Once I've stated and justified why those two triangles are congruent, then I know that the other three parts, other three corresponding parts, have to be congruent as well. Well, these angles, this angle and that angle, are corresponding parts in those two congruent triangles, so they got to be congruent. CP/CTC. So I got two facts about these triangles. I need a third. What's the third fact that I'm going to be able to use? Got to have three facts when you prove triangles are congruent. What am I missing? Come on, friends. Emily? There you go. They share segment KD. So segment KD is congruent to itself, and that's the reflexive property of congruence. I'm going to put 4 congruency marks just so it doesn't get mixed up with anything else. So now I know that this triangle down here, KDE, is congruent to triangle KDI because of side, angle, side. So I know that triangle KDI is congruent to triangle KDE by side, angle, side. I'm going to stop here. Is everyone comfy? We okay? Do I need to re-explain one of these steps? Okay. Now that I've proven that these two triangles are congruent using side, angle, side, I'm now going to use CP/CTC again, but for these new congruent triangles. I'm going to say, well, since these are the exact same size and shape by side, angle, side, that means that this corresponding angle and, this angle that's corresponding to that angle, they have to be congruent. The notation that I did is one arc of congruency, and I just put a line in the middle of it to differentiate between those congruent angles, rather than drawing 4 arcs. Well, because these two angles are corresponding and the triangles are congruent, then I know these angles are congruent by CP/CTC. From there, the only way you can have two angles that are congruent and supplementary is if their measures are equal to 90 degrees. And if an angle has a measure of 90 degrees, then it's a right angle. If these two lines are intersecting to form right angles, then they have to be perpendicular, by the definition of perpendicular lines. So that would be the proof of proving that these two segments are perpendicular. The textbook is expecting you to be there, to be at that level, and so am I. That they can, or I can just ask a simple question, like, hey, why are those diagonals perpendicular? And this is what we need to produce. And I stopped at proving those two triangles were congruent. I had to say that these angles are congruent because the CPCC, then I would just state that they're a linear pair, and then say that they're supplementary, and then say that their measures add up to be 180 degrees, so on and so forth. So that was all for part B. Proving that proving that the diagonals are perpendicular. So with that, part C, it asks us to complete the following list of properties of a kite. It says think about the angles of a kite as well as the segments. Notice how it says segments, not just think about the sides. It's talk about the diagonals. Think about what they're doing. How are they interacting with the opposite angles? Do you know anything about opposite sides? Do you know anything about opposite angles? So on and so forth. So they give us the first three properties. Exactly, the first one, exactly two pairs of consecutive sides are congruent. How do we know that? Not a trick question. How do we know that that all kites have exactly two pairs of consecutive sides that are congruent? It's the definition. Sweet. Number two, one diagonal divides a kite into two congruent triangles. We proved that. We drew in this case, segment KT, and that divided this this kite into two congruent triangles. So that's always true for kites. And then the third thing that we proved was that the diagonals of a kite are perpendicular, and we proved that. It was kind of a long proof, but nonetheless we know, and we're capable of doing so. After that, they left three blanks. There's a lot more properties about kites, and it's all written right here. So I want you to brainstorm with your neighbors and talk about, okay, what else is true, is always true for all kites? And literally all the information's right there. So as the memory begins to digress, let's talk about this. Now, acknowledging that this is new information for all of us, I just want to hear what you think. Throw me some conjectures. They may be right, they may be wrong. If your classmate says something wrong, we don't look at him or her and say, wow, you're an idiot. Okay? They're bold enough to say what they think. So, could be right, could be wrong, but what are we thinking? What do we see? What's up, Emily? When you draw in the two diagonals, it creates what?
Two pairs of congruent triangles.
Sweet. So you're talking about these two that we proved were congruent, and then also these two that we proved were congruent? Cool. Yeah, and these two triangles are congruent as well, for the same reason, side, angle, side. Cool. What else? Kyle, what's up, man?
One pair of opposite angles are congruent.
Perfect. And that's actually number 4, so you can go ahead and write that. That only one pair of opposite angles are congruent. In this case, for this kite, the angle I and angle E. Well, I'll let you write them. And you need to write one pair, exactly one pair of opposite angles are congruent. Exactly one pair of opposite angles are congruent. And we know that because when we drew in this, when we're talking about strictly the green ink, when we drew in this diagonal, segment KT, it created these two congruent green triangles. And then we use CPCTC to say that all of the angles are congruent. Well, this angle here is congruent and corresponding to that angle there. And those will always be one pair of opposite angles. So, okay, good. What else do we know? So, yes, one pair of opposite angles are congruent. The other pair of opposite angles will always be bisected by the diagonal. So you can go and write that one down as well. Well, that's a continuation of number 4. That one pair of opposite angles are congruent. The other pair of opposite angles will be bisected.